Hello. I just wanted to make a little video on RF interference in drones. It's sort of, RF is always a kind of voodoo kind of thing. So, and I've been having trouble. So it's like, you hear on blogs, are the motors interfering with it or are they not? Okay, so I'm going to try to give a rundown of what's happening here. So we got the laptop. This is our ground control station. This is our telemetry transmitter. Can you see it? So that's transmitting telemetry at 433 megahertz. Now over here on the drone, which is looking a bit worse for wear at the moment, we have our telemetry transmitter, which doesn't feel like it's screwed up tight. Okay, but like I said, it's so close it's not really going to matter that much. So that's transmitting on 433 megahertz. Now down here we have our antenna and our HackRF, which is plugged into HD SDR. So this is the signal we're currently getting. Alright, so this is the signal that we're currently getting. So what I'm going to do is unplug the drone. Alright, so I've just unplugged the power from the drone. You can see that the signal stops. And this is a really, really wide band. So over here it's like 428 megahertz. Over here it's like 437 megahertz. Okay, so I'm going to plug it back in again. And straight away you can see the signal being transmitted. And it's taking up a huge bandwidth. Now I'm not going to try to decode that or anything, like I'm not going to go that far. So now what we're going to do is turn on the motors and see what happens. There we go. So you can see there's currently no change whatsoever. Doesn't look like there's any interference coming through.
Manual flight mode. Control stick input.
We get our like antenna.
Disarmed. Manual flight mode.
So yeah, that was with the antenna, nice and close. We tried it first time with it down here, second time with it up and close. Couldn't spot any interference at 433 megahertz. So the next one we'll try is 2.4 gig, because that's generally what the computers transmit on Wi-Fi. Alright, so we've just switched it to 2.4 gig, and of course, as you can imagine, so around here is channel A, which of course, for Wi-Fi, which of course is booming, and then it goes up to, well, 5 megahertz either side. So you presume that these are the other channels that are happening. Alright, so let's turn the motors on and see if we get any interference.
Armed. Land flight mode. Failsafe enabled. No manual control stick input. Disarmed. Manual flight mode.
Okay, so I couldn't spot any interference there, so we had the antenna just sitting down underneath it. This time I'll put it, let's get it right involved. Okay, so that's not touching anything metal, but that's right on the top there. And this should be enough to pick up interference if it's happening.
Pre-flight. GPS speed accuracy too low. Armed. Land flight mode. Failsafe enabled. No manual control stick input.
There's something happening there, maybe?
Disarmed. Manual flight mode.
Alright, now the motors are off again. Let's see if that goes away.
Pre-flight. GPS horizontal pass error too high. Armed. Land flight mode. Failsafe enabled. No manual control stick input. Disarmed. Manual flight mode.
Alright, I definitely can't see anything obvious happening in there. If anyone has ideas on how to improve this test, I would love to hear it. So the next thing is the GPS. GPS seems to be the thing that gets interfered with, and they always have it on the high kind of post. So what we'll do next is we'll find the GPS frequencies and see if we can find some interference from the motors. Okay, I've done a bit of Googling, and it looks like GPS is sent on two different frequencies. We have L1, which is 1575.42 megahertz, and L2, which is 1227.6 megahertz. So we're set up on the first one here, 1575.42, and the spectrum looks clean and clear. We may have to turn the gain up, I'm not sure, but let's just give it a try and see what happens.
Pre-flight. GPS speed accuracy too low. Armed. Land flight mode. Failsafe enabled. No manual control stick input.
So I see a few little flashes of things.
Disarmed. Manual flight mode.
Okay, those didn't really see anything, so I think we'll turn the gain up and see how that goes. Oh, gain's already gone full. What does that one do? Amp. Alright, so we're getting a bit more action here now. And the meter over here is looking pretty good. So, let's give it a go.
Pre-flight. GPS speed accuracy too low. Failsafe enabled. No manual control stick input. Armed. Land flight mode. Disarmed. Manual flight mode.
It's hard to tell. We'll try and slow down the waterfall. Okay, so now we're zoomed in. We've got a lot much smaller, so 1575 and 1575 900, 1575 100. So we're much more zoomed in. So we'll just let that run for a little bit until this goes off the top. So I would presume that this is the signal coming from the satellites at the moment. Okay, let's turn the motors on.
With light, GPS speed accuracy too low. Failsafe enabled. No manual control stick input. Arm. Land flight mode. Disarmed. Manual flight mode.
I can't really see any difference there. Nothing major. Let's try it one more time.
With light, GPS speed accuracy too low. Failsafe enabled. No manual control stick input. Arm. Land flight mode. Disarmed. Manual flight mode.
Well, that's questionable, but nothing major. So we'll try the other frequency, 1227 megahertz, and see if we get any luck with that. Once again, it looks like we're getting pretty much the same pulse, so I'd say that's from the satellite. We are actually indoors as well, I should point out, so the signal strength will be very small.
With light, GPS speed accuracy too low. Failsafe enabled. No manual control stick input. Arm. Land flight mode. Disarmed. Manual flight mode.
Looks pretty clean and clear. Try and adjust these things. So we get a bit more color. Alright, so you can still see the signal pulse from the GPS satellite. So let's try it again.
With light, GPS speed accuracy too low. Arm. Land flight mode. Failsafe enabled. No manual control stick input. Disarmed. Manual flight mode.
Well, I'd say I can't see any interference at all. So, yes, that was our setup. I would have thought we would have got something at least. I just thought of one more thing that I've read on blogs that makes a lot of interference on drones. The good old humble GoPro. So this is a Hero Black 7. It does Wi-Fi to your phone, I think. So we're gonna give it a go. It's gonna be hard to test it around 2.4 gig. I've turned off all of the Wi-Fi devices I have at the moment, to see if we can cause some kind of interference. Alright, so we'll go through and test those same frequencies. Okay, so this is at 2.4 gig, thereabouts. So you can obviously see channel A just from picking up wireless from all of the other houses around. So there's lots. Alright, but now we have our antenna and our GoPro. We'll see if we can make anything happen. Once again, I'm just going to hang on. I can't hold both of these things. All right. Wow, what was that? So I'm just going to record with it. Alright, I'm just going to turn it off. So now that it's off, we'll see if any of these happen. Oh, there it goes. Alright, we'll turn it on again. Now it's recording. Now it's off again. So I feel like some of these were probably from it. But yeah, it's very hard to monitor anything in the 2.4 gig band because there's just so much of it. Bluetooth is 2.4 gig too, obviously, as well as Wi-Fi. So we'll try the other frequencies. We'll try the 433 megahertz and see if we get anything there, and the GPS frequencies. Just while I was waiting, look at this. Wonder what that is. It's like the Doppler thing from the airplane that flew over or something. The Doppler shift of the transponder, maybe. Alright, so once again we have our GoPro. It's currently off. Let's turn it on and see what happens. No, can't see anything there. Hit record. Can't see anything. And now it's off. And we're still picking up this signal, which is still moving. Alright, we'll switch up to the GPS frequency. Okay, so now we're at GPS frequency 1, which was the L1. I've got the gain down a bit, so it's a bit calmer, but you can still see like the GPS frequency we're picking up there. There's a couple of little other things, not really sure what they are. But here we go. So, GoPro, currently off. Ooh! Was that a little nudge or something? Let's try and hit record. I feel like we're getting some kind of potential interference. Alright, let's turn it off. Alright, now it's off. Let's turn it back on. Now it's on. Oh, we're getting a little line back here again. Let's hit record. There's another one. I'm getting a few little... I'm going to put this to a maybe. This could be a maybe getting some interference on the GPS. Let's stop record. Start record. Right, I'm going to turn it off. And see if this goes away. It's also, yeah, you can see a bit of something there. Well, yeah, this seems to have gone away. So there was a few streaks of signal coming up, so I'm going to say that's a yes. I think your GoPro can interfere with the GPS. Let's try the L2 frequency. Alright, so now we're on our L2 frequency. Once again, we've got a fairly calm looking spectrum. So let's get our antenna and GoPro and turn it on. Can't see anything so far. Hit record. Alright, we'll turn it off again. That's off now. Turn it on again. Hit record. Alright, so I feel like at the L2 frequency it had no difference. What I might do is go back to the Wi-Fi frequency and turn the gain right down so we can try and get less of all of the neighbours' Wi-Fi. Let's see if we can pick up the actual signal that's coming from this. So let's give that a go. Okay, so we've turned all of the gain all the way down. We're still getting a few bits and pieces. Okay, so let's turn on our GoPro. Yeah, so I'd say that is definitely coming from the GoPro. It's much, much stronger. Hit record. Stop record. Not a lot of action. Alright, we'll turn it off. Alright, well I think the conclusion is that from what I could see there was very little things causing interference from the RF. The GoPro obviously produced Wi-Fi, but it's meant to do that to connect to your phone. Looked like it may have been interrupting the GPS slightly, the GPS L1 frequency. There was potential for that. Other than that, not even sure. The motors didn't seem to affect anything. Yeah, must just be, not even sure. But couldn't really find any RF interference, so mystery solved for now. But if you have any ideas on how to get a better test going, please let me know in the comments, and I'll happily do it again if we can find causes to problems or solutions to problems. Okay, so we're back. I forgot the most important one, the controller, which also works at 2.4 gig. So I feel like this is probably going to give the most interesting results out of them all. Like a Wi-Fi is just like a single kind of spectrum band. You know, the other, well, the telemetry was quite interesting with the pulses. But yeah, we'll switch this on first without the receiver and just see what happens. See if it's sending out a heartbeat or something. And then switch on the drone so it's receiving signals and see what happens when we move the move the things. So we're at 2.4 gig. We've got our trusty old antenna. We've got our trusty old antenna that I'm just going to do this over here. Okay, turning it on now. There you go, you can immediately see some signals there. So yeah, we're getting these pulses here and these pulses here. So we'll turn it off. I'll just turn it off again to make sure that that's from us. Okay, now it's off. Alright, so you can see the signals have stopped. We'll just let that go for a minute to make sure. Okay, next I'm going to plug in our drone. Okay, so the drone is on. You can see there's nothing transmitting at 2. I've got the nav queue off at the moment, so there's nothing transmitting from the drone at 2.4 gig. Okay, now let's turn on the control. There we go. Alright, so this is definitely just the communication with the drone receiver. I'll just try a bit of a higher frequency. We'll give it one last test. Okay, I've changed it to 2469 megahertz, which is just above, and look what we've discovered. So I'm going to turn the controller off just to check. I'm going to turn the drone off first.
Communication lost.
Alright, the drone's now off. And look at that. So yeah, that was all coming from this. So let's start off by turning this on first. Bam, look at that. That's just coming from, the only thing that's switched on right now is the receiver. So if you're broadcasting video in any of these ranges, or Wi-Fi, you might be getting interference from that. So let's turn on the drone. Okay, let's try the controller. That's up, down. If I can pull this over. Hang on, it's not good. So I'm just moving the joysticks around. The switches.
Altitude flight mode. Reject position control. Manual flight mode. Reject auto return to launch.
Alright, just moving the joysticks. Even just sitting there without switching anything, it just pulses. And let's try and go a little bit lower on the spectrum. So over here we'll just take it down a few frequencies. Oh, here comes another bunch. So yeah, there's plenty of action from the RF controller. all the way through the spectrum. We're back at 2.4. So it looks like our humble controller actually sends pulses all the way through the 2.4 gig spectrum, right up to probably 2.5, I guess. Let's see if we can jump up to there and see. Okay, we'll jump up to 2.5. Alright, so it seems pretty calm now. How do we do this? We go that one. You can see it starts there. 2.48. $2.48. And there's heavy through here. Look at that. Fire. Alright, now we're down to 2.4 again, which should be a little band around here somewhere. Yep, there it is. Let's try to keep going down and see what happens. $2.39, and it looks clean and clear. So now I'm curious to see what happens when we try and transmit video from the NavQ over Wi-Fi with this switched on. So let's give that a go. Alright, just took me ages because the NavQ was on the wrong Wi-Fi and I couldn't log into it. So now we have the camera image coming from our NavQ over here, which is a bit oddly placed at the moment. So what I want to do is move the controller around and see if we can get it to interfere with the video that's being transmitted. So currently it's going from the NavQ, it's going to a wireless router, which is over here, so obviously it's very close. We've got our little antenna so we can see some what's actually happening. Yeah, so, and obviously it's a little bit unrealistic because I'm gonna like put it right up next to it, but we'll see what happens. It's my attempt to. So now I've put the NavQ, you can see the antenna there right on top of the receiver, which is all really badly placed from an afternoon of crashes and fixing it in the park. Okay, so we'll bring this in here, moving the thing. You can see the controller there. Oh, bit of pixelation there, but I think that's just because we got too close with the
reject toggle, return to launch. Reject toggle, return to launch.
Can't get anything. So we'll do one more, we'll turn the motors on, see if we can just get some kind of scrambling of the video. Oh, can't get any video interference. Alright.
Manual flight mode.
Well, I think that solves that mystery. So, yeah. The Wi-Fi is too intelligent to be interfered with by the receiver, by the remote control. Alright, thanks for following me on my experiment. Ciao ciao.